Introduction to Trigonometry. In this video, we will see introduction and trigonometric ratios of the angle. We'll go to the next slide. What is trigonometry? Trigonometry is the study of relationship between the sides and angles of a triangle. Okay. What are the sides? AB, BC, AC are the sides. Okay. And the angles are angle A, angle B and angle C. Okay. What are the applications of trigonometry? Application means uses, where we use the concepts related to trigonometry to solve the real-time problems, or distances or heights can be found by using trigonometry. How the word trigonometry is derived? The word trigonometry is derived from Greek words tri meaning three, gon meaning sides, metron meaning measure. These are the introduction concepts. We'll go to the next slide. In this slide, we will see trigonometric ratios of the angle. Okay. Alright. Consider this triangle. Triangle ABC. Okay. And consider this angle A. How do you write angle A? Angle CAB, which is angle A is an acute angle. What is acute angle? If an angle is less than 90 degrees, okay, between 0 and 90 degrees, we call such angles are acute angles. Now, angle A is acute angle, angle B is right angle, which is 90 degrees, okay. Angle C is how much? 90 minus this acute angle is nothing but angle C. We will concentrate this diagram, okay, and consider angle A. The side BC faces angle A. Can you see this side BC? This side BC is facing this angle A. That is why we call it as side opposite to angle A. Okay. Side BC is called side opposite to angle A. Okay. Then AC is hypotenuse of the right angle triangle. Right angle triangle is also called as simply right triangle. AC is hypotenuse. You are aware of this. Okay. Now, side AB. This is adjacent to angle A, right? That is why we call it as side adjacent to angle A. Side AB is called as side adjacent to angle A. Why we are calling them? You will appreciate in the upcoming slides. Please remember, this is side adjacent to angle A, this is side opposite to angle A, that is BC is side opposite to angle A, and this AC is hypotenuse. We'll go to next slide. Now consider the same triangle ABC, and consider angle A. As we have already understood that side AB is called side adjacent to angle A, and side BC is called side opposite to angle A, and AC is hypotenuse. See, the ratios involving the sides of right triangle are called trigonometric ratios. Correct? Okay. We'll appreciate this statement in next statements. Okay. The trigonometric ratios of the angle A in right triangle ABC. Right triangle ABC. Okay. It's a right triangle, right? Okay. Now, these only 6 trigonometric ratios. Okay. These trigonometric ratios, mathematicians, okay, developed these ratios. What they said was, okay, sine of angle A, sine of this angle A, okay, is equal to sine A. Or we'll start like this. they put a ratio, they defined a ratio, they considered angle A and they given a ratio side opposite to angle A divided by hypotenuse. To this ratio, they given a name sine of angle A, which can be specified in simple terms as sine A. Okay, space is there, sine space A. We'll say it is sine A, which is equal to BC by AC. Correct? This is a ratio, right? Okay. Okay. And I have specified references. If you have a doubt what is ratio, you can refer to reference. Okay. In every slide, wherever possible, wherever required, you need a reference to previous concepts related to trigonometry. I was specified in the reference section. Okay. Alright. What is sine of A? Opposite side by hypotenuse. Okay. That is BC by AC. Correct? That is sine A. Then they define another ratio considering angle A side adjacent to angle A divided by hypotenuse, that is AB by AC. That is AB by AC. You have to give a name, right? What mathematicians did was they called it as cosine of angle A. Okay? Simply we can call it as cos A. This is another ratio, right? Okay, are you appreciating the statements? These ratios involving the sides of right triangle are called as trigonometric ratios. These are trigonometric ratios, right? They have written, mathematicians have specified that ratio of side opposite to angle A to side adjacent to angle A, they called it as tangent of A or tan A. Okay? Which is BC divided by AB. This is another ratio. Coming to fourth one, cosecant of angle A, okay, which is simply called as cosecant A is the ratio of hypotenuse divided by side opposite to angle A, that is BC. That is hypotenuse is AC, side opposite to angle A is BC, which is AC by BC. Can you just look at this? Why I have written exactly opposite to number 1? Exactly opposite here I have written. If you look at very carefully, the cosecant of A is equal to AC by BC, but whereas sin A is equal to BC by AC. Is it reciprocal of this? Yes, it is. AC by BC is reciprocal of this, correct? BC by AC. AC by BC is reciprocal of BC by AC. What is BC by AC? Sin A. That means, can we write cosecant A is equal to 1 by sine of angle A? Yes, we can write that. Okay. So, we can call it as cosecant A is the reciprocal of sin A. Okay. Right. What is the next trigonometric ratio? They said, they defined a ratio hypotenuse, that is AC, divided by side adjacent to angle A, AC by AB. Okay. Okay, this is called secant of angle A. Simply we can call it as secant A. If you look carefully, it is reciprocal of AB by AC, correct? That is reciprocal of cos A. So we can write that secant of angle A is reciprocal of cosine of angle A, or simply we can say that secant A is equal to 1 by cos A. Okay, let us go to the last ratio. They defined a ratio, okay, side adjacent to angle A divided by side opposite to angle A. Okay, that is AB by BC. See, always these ratios are in relation to a particular angle. Which angle we have considered here? Angle A. Okay, based on angle, considered angle, this becomes opposite side, this becomes adjacent side to this angle. Okay, and what is the last one? Cotangent of A. It is equal to cot A. Okay, side adjacent to angle A divided by side opposite to angle A, which is AB by BC. AB by BC. Can you see this? This is AB by BC is reciprocal of BC by AB. What is BC by AB? We have already learned that it is tangent of A. So can we write this AB by BC is 1 by BC by AB, which means 1 by tangent of A, angle A, correct? Or simple terms, we can say that cot A is the reciprocal of tan A. Okay, alright. So we have learnt 6 trigonometric ratios. See, these are defined by mathematicians. Why they define like this? You will appreciate in upcoming slides as well as upcoming examples, upcoming exercise problems. You will really appreciate. Please memorize these ratios. Okay, you must memorize these ratios. Or if you draw the schematic for triangle ABC and you consider this angle, you can very well write it. Okay, just once you memorize it, you can recollect. Okay, next time onwards. Okay, these are trigonometric ratios for angle A in triangle ABC. Okay, now and let us go back to previous slide once. Okay, can you see this? Same triangle ABC, if you consider angle C, then positions will change. Can you see? The positions of the sides change when you consider angle C in place of angle A. And if you consider angle C, then which is opposite side? AB becomes opposite side to angle C, and BC becomes adjacent side to angle C. Whenever you say C, simply you can call it a opposite side, or this is adjacent side. But if you want to be more specific, you will say side opposite to angle C, side opposite to angle C. But once you become expert, right, simply you will say opposite side and adjacent side and hypotenuse. You will become expert. Okay, just wait. This we have completed. We will go to the next slide. Then we will try to write the ratios for angle C, correct? If you consider angles, consider this diagram. Don't consider this angle A. Now you consider triangle ABC and consider angle C. Okay, consider angle C. If you consider angle C, side opposite to angle C is AB, side adjacent to angle C is BC. Now you see, sine of angle C is equal to sine C. It should be opposite side by hypotenuse, right? This is opposite side. Now onwards, can I call opposite side simply without specifying angle? Why? We are concentrating on angle C only. Then this is opposite side by hypotenuse, which is AB by AC, AB by AC. Then cosine of angle C is equal to cos C, okay, is equal to side adjacent to, that is adjacent side by hypotenuse, or side adjacent to angle C by hypotenuse, which is BC by AC. Now the third ratio, that is tangent of angle C, which is tan C, side opposite to angle C divided by side adjacent to angle C, that is opposite side by adjacent side, that is AB by BC. Yes, AB by BC. Then we will come to cosecant of angle C, which is equal to cosecant C is hypotenuse by side opposite to angle C, which is AC by AB, which is the reciprocal of sin C. Then we can call it as cosecant C is reciprocal of sin C, or cosecant C is equal to 1 by sin C. Okay, we'll go to the next one. Secant of angle C is equal to secant C is equal to hypotenuse by side adjacent to angle C, or simply we can say hypotenuse by adjacent side, which is AC by BC. If you see, cosecant cos C is BC by AC. AC by BC is reciprocal of BC by AC, which means that we can say that secant C is reciprocal of cos C, which is 1 by cos C. Next, cotangent of angle C or cot C is equal to side opposite to angle C, side adjacent to angle C divided by side opposite to angle C, which is BC by AB, which is reciprocal of tan C. Okay. We have learnt 6 trigonometric ratios which are specified by mathematicians. We will not break our head why they define like this. We will appreciate these trigonometric ratios, okay, in upcoming slides, problems and exercises. You will appreciate the uses of trigonometric ratios in subsequent videos. Okay. We'll go to next slide. This slide specifies some notes. Means you should be very cautious. The symbol sin A is used as an abbreviation for the sine of angle A. Okay. This is here. This, if you see, sin A is abbreviation for sine of angle A. It is not product of sine and A. Okay, sin A is not the product of sine and A. You should be very cautious. Sin separated from A has no meaning, correct? Okay, this separation has no meaning. Okay, okay. Similarly, cos A is not the product of cos and A. Okay. Similar interpretation follow for other trigonometric ratios tan A, cosecant A, secant A and cot A. Okay, alright. In this slide, what we are learning? We are learning that sin A is not product of sin and A. It is abbreviation of sine of angle A. This is sin A. There should be a space between sin and A. Okay. Similarly, cos A, tan A, cosecant A, secant A and cot A. Okay. We have completed these notes. Then we will go to next slide. Now, there is like, suppose you consider this triangle PAM and CAP. Okay. If the angle remains same, okay, will it depends on the lengths of the sides or not? We have to prove that. See, what is the theorem? What is this? The values of trigonometric ratios of an angle. Which angle? This angle is, we are considering this angle A. Okay, the values of trigonometric ratios of an angle, like let us say of this angle A, do not vary with the lengths of the sides of the triangle. It does not vary with the lengths of the triangle. What are the lengths? AB is the length, okay, and AC is, suppose if you write sin A, what is sin A? BC by AC, okay, BC by AC, correct? BC is opposite side to angle A and AC is the hypotenuse, BC by AC. What? It will have some value, right? BC by AC. And what is the sine of angle A for triangle PAM? It will be like PM by AP. Okay, what is the ratio? It will be same. What we are going to prove here is, in this slide, the trigonometric ratios does not depend on the sides of the triangle unless unless the angle is changed. Okay, if the angle A is fixed, if you keep on changing, if you consider any number of similar triangles, if you consider similar triangles, the trigonometric ratios remains the same. That we are going to prove. Now you see, proof. Take a point P on the hypotenuse AC. First we are considering triangle ABC. Okay, consider triangle ABC. What you will do is consider a point P on AC. Okay, you consider a point P on AC, on hypotenuse. Okay, and you extend, or you can consider another point Q which is extended. If you extend AC hypotenuse up to here, you consider this point Q. Okay. Now what you do is you draw a perpendicular from P to AB. Okay. You draw a perpendicular to AB which intersects at point M. Okay. You draw another perpendicular. You extend the base of the triangle ABC. This ABC, the base AB you extend, and this perpendicular from Q will intersect at point N. Okay. Now how many triangles we have? Triangle PAM is one triangle. Okay. And another triangle is CAB. Okay. Another triangle is QAN. Okay. These are the three different triangles we can see. Okay. Actually, we started with triangle CAB, but we constructed to form triangle PAM and triangle QAN. Okay, for this, which involves the same angle A. Okay, now is triangle PAM is similar to triangle CAB. Okay, yes, they are similar. How they are similar is using angle similarity criterion. The triangles PAM and CAB are similar. Suppose if you see, consider PAM. Okay, what is this angle? Some, let us say, x degrees. Okay, and what is this angle? 90. And what is this angle? It will be 90 minus x, right? Angle P will be, angle M is 90 degrees. And now consider this triangle CAB. This angle is angle A, which is x degrees, and this angle B is 90 degrees, and angle C is 90 minus x. That means angle P and angle C are equal, which means angle A is equal to angle A of PAM is equal to angle A of CAB, and angle M of PAM triangle is equal to angle B of CAB, and angle P of PAM triangle is equal to angle C of CAB triangle. That means what? For the triangles PAM and CAB, all the three angles are equal. Correct? Corresponding angle mean to say that corresponding angles are equal. If corresponding angles are equal, then we'll say that. Okay. You know, in triangle, if two corresponding angles are equal, right? Obviously, the third angle will also be same. Okay. Then, considering, we can reduce it to angle similarity. So, what angle similarity says? If two angles of a triangle are respectively equal to two angles of another triangle, then by the angle sum property of the triangle, the third angles will also be equal. Just now I had explained that angle P is equal to angle C. Okay. Therefore, angle similarity criterion can also be stated as if two angles of one triangle are respectively equal to two angles of another triangle, then the two triangles are similar. That means what? This angle and this angle, corresponding angles of PAM and CAB are equal, then the corresponding sides are in proportion. Okay. Then corresponding sides of the triangles are proportional. Means what we have from this? We have AM by AB. Okay. The ratio of the bases is equal to ratio of the hypotenuse AP by AC, similar side, just I am specifying the name, that's it. And what is the altitude? MP by BC, MP for this triangle PAM and CB for this triangle CAB. We got it right as per the using EA similarity. Now consider these two. Okay, consider these two. AP by AC is equal to MP by BC. From this, what we can do? Okay, you move this to here, you move this BC to here. What happens? MP by AP is equal to BC by AC. What is MP by AP? Consider this triangle PAM. Okay, what is MP by AP? Just now we have learnt in the beginning, opposite side to angle A. Opposite side by AP hypotenuse is nothing but sin A, considering MP by AP. Now consider BC by AC. What is BC by AC? BC, consider triangle CAB. Okay, BC is opposite side and AC is hypotenuse. Then is nothing but sin A. Which means that we have found that it is sin A, correct? That means what? In triangle PAM and in triangle CAB, the ratios, the trigonometric ratio sin A is equal. Okay? Okay. Now consider these two. AM by AB is equal to AP by AC. Now move this AP to here, AB to here. Then we find AM by AP is equal to AB by AC. AM by AP is what? Adjacent side, right? Consider this triangle PAM. Adjacent side is AM divided by AP. AP is hypotenuse for this triangle PAM. This is nothing but cos A. Alright. Now consider this triangle CAB. What is the cos B? Cos A, sorry. What is the cos A? AB by AC. That is AB by AC cos A. What it's trying to say? It is independent of the sides of the triangle, correct? Now we consider another place. Consider AM by AB and MP by BC. Now what you do? Move this AM to here and move this BC to here. Then it becomes MP by AM is equal to BC by AB. What is MP by AM? Now consider MP is opposite side and AM is adjacent side to angle A for the triangle PAM. Then it's nothing but tan A, right? Opposite side by adjacent side is tan A. Now what is tan A for CAB? Opposite side is BC and adjacent side is AM. Adjacent side is AB. That is BC by AB is nothing but tan A. Now what we have understood here, this shows that trigonometric ratios of angle A in triangle PAM not differ from those of angle A in CAB. Correct? Just now we proved, right? Sin A does not change until unless this angle is changed. This angle is constant as per the diagram and construction. Right? Now we'll try to see whether CAB is sin A is same, but the trigonometric ratios are same across CAB triangle and QAN triangle. Alright, CAB triangle and QAN triangle. Okay, right. So similar, using the same OA similarity, triangle CAB and QAN are similar. Okay, which means that the corresponding sides are in proportion. Then we can write that AN, you consider first this triangle QAN. Okay, AN divided by AB is equal to AQ, hypotenuse AQ divided by AC, hypotenuse of the other triangle, and the QN, this altitude or height QN by BC. Now consider these two pairs, okay, this pair you consider, AQ by AC is equal to QN by BC. Now what you do is, you send this BC to here, AQ to here, QN by AQ is equal to BC by AC. QN by AQ, QN, what is QN? Opposite side to angle A, okay. What is AC? What is AQ? Hypotenuse for this triangle QAN is nothing but sine A in triangle QAN. Similarly, in triangle CAB, what is sine A? BC by AC, right? BC by AC, correct? So now what we have understood? The values of the trigonometric ratios of an angle, of which angle? This particular angle does not vary with the lengths of the sides of the triangle. If the angle remains the same, the condition is if the angle remains the same. Okay, we'll go to next slide. Can you see here? Some notes we will understand. Okay, what are the notes? For convenience, sine square A can be written as sine A whole square. Cos square A can be written as cos A whole square, etc. That means, etc. means tan square A, we can write it as tan A whole square. Cosecant square A, we can write it as cosecant A whole square. Similarly, secant square A, we can write it as secant A whole square. Cot square A, we can write it as cot A whole square. Now, consider cosecant A is equal to sine inverse A. We have to say that sine of A whole power minus 1. This we have to specify as sine inverse A. But remember, sine inverse A is not equal to sine power of minus 1 A. Sine power of minus 1 A, okay, has different meaning, which will be discussed in higher classes. That means you can ignore this, okay. But in the exams, they may ask sine inverse A is equal to sine to the power of minus 1 A. So you have to say false, okay. Similarly, for other trigonometric angles also, we can specify these notes. Sometimes the Greek letter theta is used to denote an angle. See, earlier we were saying angle A. We can call angle A as theta. Okay, like that. We'll go to next slide. Suppose if we know any one of the ratios, okay, can we obtain the other ratios? That we have to see. Can we do that? Okay, you know the ratio, one trigonometric ratio. Can we obtain other ratios? We'll see that. Now consider this triangle ABC, okay, and sine A, it is given that sine A is equal to 1 by 3. Then what does it mean? Sine A, what is sine A? Opposite side to angle A, that is BC, by hypotenuse, that is AC, that is BC by AC is equal to 1 by 3, which is given, correct? Okay, that is the lengths of the sides of BC and AC of the triangle ABC are in the ratio 1:3, correct? When you say BC by AC is equal to 1 by 3 means what? It is 1. These sides are in the ratio 1:3. Can we say that? So, can we assume that BC is equal to K, then AC will become what? 3 times K, right? Just now it is given, right? 1 by 1:3. These sides are in the ratio of 1:3. If this is 1, it will be 3 times, correct? If it is K, 1K, it will become 3 times K, correct? Yes. Where K is a positive number. Okay. To determine the other trigonometric ratios for the angle A, what we require? You need AB, right? Okay. See, you know sine A. Very well you can say that cosecant A is reciprocal of sin A, correct? Correct. Simply we can say it is 3. Correct? So what we'll do, but we need other trigonometric ratios, 6 trigonometric ratios we have to derive from this given statement sin A is equal to 1 by 3. Okay. Now, this is a right angle triangle, correct? In right angle triangle, hypotenuse is equal to square of the hypotenuse is equal to sum of the squares of the other two sides, correct? Which means AC square is equal to AB square plus BC square. That means we need AB, right? Then what we will do? You keep this AB square here and send this BC square to this side. Now AB square is equal to AC square minus BC square. Okay. AB square is equal to AC square. What is AC? 3K. 3K whole square. Okay. What is BC? K. K whole square. So AB square is equal to 9K square minus K square. So AB square is equal to 8K square and AB is equal to square root of 8K square. Can you write 8A as 2 into 4? Yes, we can write. Then it becomes AB is equal to plus or minus 2 root 2 K. AB is equal to, AB can have the value plus 2 root 2 K or minus 2 root 2 K. Minus 2 root 2 K is not valid for the side AB. Why? Can the side be negative? It cannot be, right? Length of AB cannot be negative. When it cannot be negative? If this is K and this is 3K, this cannot be negative, correct? Alright. It should have at least some length. That means minus 2 root K is not valid. Now what is the value of AB we got? Plus 2 root 2K. Now what is cos A? Cosine of angle A in this right angle triangle ABC is equal to cosine of angle A, that is cos A. Cos A is equal to adjacent side to angle A, that is AB, divided by hypotenuse, that is AC. That is AB by AC is equal to, what is AB? We just now found 2 root 2K. What is AC? 3K. Okay, 3K. Now it will become 2 root 2K. Right? Similarly, we can obtain the other trigonometric ratios for the angle A, of the angle A. Why? Because we know all the sides, right? We know simply trigonometric ratios are what? It is a relation. We'll go to first slide. What is trigonometric ratios? Ratios involving the sides of right triangle are called as trigonometric ratios. That means what? If you know the sides, you can write all the trigonometric ratios. Okay, we have completed this. Okay, alright. These are the concepts related to introduction as well as trigonometric ratios of the angle. Okay, alright. With this, we complete what we have completed: introduction, concepts we have understood, that is the background related to trigonometry we have understood, and trigonometric ratios of a particular angle, concepts we have understood. Okay, with this we conclude this video, first video. Okay.